Section 11.6 is on geometric probability. So you guys had a couple questions like this on your homework, so I think you guys probably know how to do this, but we'll kind of fill this in so you have it. So probability is a number that's between 0 and 1. So if something has a 0 probability of happening, that means it's not possible at all, right? If something has a 1 for its probability, what does that mean? It's happening. Yeah, it's going to happen. It's a 100% chance, okay? So an event with probability of 0 cannot possibly occur, and an event with probability of 1 is certain to occur. So geometric probability is the probability that involves a geometric measure such as a length or an area. So you might see something with probability in length. So I'm going to draw a little picture here. So it says let AB be a segment that has CD inside of it. So it contains the segment CD. If a point K on AB is chosen at random, then the probability that it is on CD is, so the probability that, let me just write P for probability. So probability equals CD out of AB. So the probability that it lands on CD, if it was going to be anywhere on the length AB, is the length of CD divided by the length of AB. Okay, and then area, so it says let J be a region. So let's say J is a square that contains region M. So let's put M as a circle. If a point K is chosen randomly on J, then the probability that that point K is on region M is the area of M divided by the area of J. So it's like the smaller area divided by the total area. So we could have lots of pictures. So this one says, find the probability that a point chosen at random on the length of CB is on the smaller length AD. So the probability that we're going to be on AD is the length 1, 2, 3, 4 units long. Do you guys see how AD is 4 units long? Divided by CB, which is, so C to B, I think it's 10 units long. So our probability is 4 out of 10, which reduces down to 2/5. Or if I wrote it as a decimal, do you guys know 4/10, 0.4, exactly. 0.4 or 0.40 if you want to see it as 40%. Right, does that make sense? All right, so number 2, so a beanbag game consists of 4 circular holes on a 3 by 4 foot board. The circular holes have a diameter of 1 foot. So going across is 1. If a beanbag is equally likely to land on any point on the target, find the probability that the beanbag goes through one of the 4 holes. So it's like a weird cornhole game. So let's do one thing at a time. So remember how I told you, as you take your test, you want to write things like the area of a circle. So the area of a single circle on that board is going to be pi r squared. What's its radius length? 0.5. So it's going to be pi times 1/2 squared. 1/2 squared is not 1.
0.25.
Yeah, 0.25, right? Or 1/4. So we get pi over 4. Well, what about the area of 4 circles then? Yeah, multiply by 4. What do we get when we multiply by 4? Pi. Yeah. What about the area of the board? So the area of the rectangle. Yeah, it was 3 times 4, right? Which is 12. So then our probability is going to be the area of those 4 circles, which was pi, and it's going to be divided by 12. So you can find that as a decimal if you want, or you can leave it as pi over 12. So as a decimal, it would be 0.262. So around like 26%. Okay, and the last one, so find the probability that a randomly chosen point in the figure below lies in the shaded region. So this is where we need to figure out what the area of those triangles are. So we know that this distance, this red distance, is what?
16.
It's 16 because we had 8 and we had 8, right? And then the distance across was 26. So our area of our rectangle, so if you just want to do like area subscript rectangle, sometimes that's faster, is going to be 16 times 26, which is 416. But now we need an area of the triangle. So for the triangle, we have like the base of the triangle, but we need the height of the triangle. Any ideas on how to get that height? we had 26, and we take out the 10, so we're left with 16 units. Then we divide it by 2. It is symmetric. Maybe I should have done some little tick marks or something to say those are the same. So we have 8 and 8. So the area of a single triangle is 1/2 base, which was 16, times height, which is 8. So we get 64. So the area of 2 triangles is what? 128, double it. So if I want the probability, I want to do the area of those 2 triangles divided by the area of the rectangle, right? So I'm going to do divided by area of rectangle, which was 416. So when I do that, 128 divided by 416, I think it reduces to 4 over 13. I wrote these numbers down earlier, which works out to be 0.308 if you want to find the decimal version. But really, probability, you could write the reduced fraction or you could write the decimal. You don't have to write one or the other. Sometimes the decimal's nice because then you can think of it as like a percentage. Okay, does that make sense? I think you guys did those on the homework anyway. Were you guys okay on the homework? Yeah. All right. No. There were some tricky ones. I think there was the one where it was like the target. So something like this. So if you have like 4 inches and you have another 2 inches, and you were supposed to find like the area of the red around. So you would first find the area by doing like the outer circle minus the inner circle, right? So you'd have like 6 squared, 36 pi. And then 4 squared was 16 pi. So when you subtract those, that gets you the area of the red portion. And then your probability then would be divided by 36 pi. So what works out nicely on these ones where you have the outer circle minus the inner circle is those pi's will go away. Because 36 pi minus 16 pi is 20 pi. And then dividing by 36 pi, those pi's cancel. So you can cancel those out. So then you just have 20 over 36, which reduces to like 10 over 18, so 5 over 9. So that answer would be 5 over 9, or I think 0.5 repeating if you found the decimal. So there's ways to do this as well. Do you guys remember that one from your homework? Did you guys get that?
Yeah.
Yeah? Okay. All right.